Bro, that was horrible. That literally just, but it's fine. I was only streaming for like 15 minutes, so that's fine. All right. It was literally just me reading my books, but all right. Respond to some Reddit things, and then we'll start in like 5 minutes. That's insane, though. Like, that's insane. I don't even know why I did that. It's fine. Good lord. Okay, I think I got through everything. Holy crap. That was fun. Okay, now the hard part. Dude, my ponytail is insane right now. Holy moly. It's definitely not gonna last through the session. Alright, now the fun part. Alright, let's do it. And these will be the study notes I get to take with me into the exam. Basically a full packet. But actually, I'm gonna wait because these are, yeah, that's fine. Oh my god. I think I'm gonna do it in pencil. If I'm being honest, I probably just need to go through the practice problems. I just need to go through the practice problems, and then if there's anything I don't understand from the practice problems, then I think that would be the best time to go back to that corresponding section. Should we go in order? I have literally no clue. Oh wait, yes I do. YP, V. Okay, yeah, this isn't gonna work. Oh my goodness. I actually can't stand having headbands or stuff on my hair. I don't even know why I did that. Alright, I think I'm gonna go through the practice problems. I think that's where I'm gonna start. Find the largest interval centered about x equals 0 on which the initial value problem IVP has a unique solution. This is already in the form linear ODE. This is already in a linear ODE form. Actually, okay. What I'm gonna do, dude, I'm lucky uncomfortable. Okay. If I raise my desk, does that? Because I want to cross my legs. Okay. Low-key uncomfortable still. Hold on. What the heck? Ugh. Bruh. Alright. I low-key want to stand by. I don't think that is gonna let me do that. So. Alright. So, P1, existence and uniqueness. Okay. We need to find the largest interval centered about x equals 0. Which is literally what this is. My thought process... Oh my lord. Okay, that's what we're gonna do. Okay, so with this in mind, what am I thinking? Do I just... The other thing... I'm thinking I set it equal to 0. I didn't even do that, actually. Does it have a... No, and this is also... This is a non-homogeneous equation with a variable coefficient, which freaking sucks. So there's no need for me to do a characteristic equation. It's not homogeneous. Oh wait, yeah, no, that's a whole different section. Let me see. Theorems. I actually love the Wronskian. I hope I get a Wronskian question, and I hope I don't F it up. Yeah, see, this is exactly what I have. I have an nth order linear ODE, and my forcing term is e to the x. Yeah, I have a non-homogeneous. Okay, the superposition principle. This is a linear homogeneous ODE and y sub 1, y sub k are solutions. Then any linear combination of c sub 1, y sub 1, c sub k, y sub k is also a solution. Vector subspaces. Linear independent on this interval, c sub 1 satisfying where c sub 1 is equal to c sub n, which is equal to 0. I remember that. But this is not what I need. And I don't need the Wronskian either. I don't believe Abel's theorem is applicable here. No. A sub n, y to the power of n plus a sub 1, y prime is equal to 0. Assume that y equals r to the x. Yeah, this is characteristic. I need something where we're looking at a non-homogeneous linear ODE with variable constants or variable coefficients. isn't it either. This is cake as well. I hope. And then repeated roots. No, that's not gonna be it either. It's not it either. Oh, I think this is it. Undetermined coefficients. Okay, so if g of x is equal to g sub 1, and it involves this, what are they talking about? Sinusoidal. Try the particular solution is equal to this and compute this. Solve for a, b, and c by matching coefficients with 3x squared. Still not what I'm looking for, because this is non-homogeneous, but it's still linear, and the coefficients are constant. Still constant. I can just divide 4 out. I don't know if I have time for this. 11 to 12, 12 to 1, 1 and 2. I don't have too much time to dilly-dally here. We've got it in standard form. Okay, let me. So. Yeah, it's already written in standard form, which has like this derivative, the second derivative of, is it y with respect to x? Because x is our independent variable here. Yeah. Second derivative of y with respect to x plus the tangent of function x times, this is just y, which is the original, is equal to e to the x. Okay, with p of x being equal to, this is our p of x. Okay, and this would be our g of x, because it's a function. Oh, actually, just kidding. P of x is equal to, this would be our q of x. P of x would be equal to, actually, I'm going to write standard form. Yeah. Okay, so the standard form is that we have, so we have this y double prime, p of x, y prime, q of x, y is equal to some function g of x, where here our p of x is equal to 0. We don't have a y prime term, but then our q of x is equal to tangent of x. And then we know that our g of x function on the right hand side is e to the x. And it is non-homogeneous, and they are variable coefficients. A unique solution is guaranteed on any interval where all coefficient functions in g of x are continuous. Okay, so guaranteed on any interval where all coefficient functions continuous. Okay. So the question becomes, where are each of those continuous? Okay, e to the x is continuous everywhere. The coefficient on y prime is just 0. Tan x. Tan x is not. Oh, negative pi. Oh, yes, yes, yes. I remember this. Oh, it fills at the endpoints and is continuous on the open interval. Am I tripping? Sine over cosine. Sine of 0, cosine of 0. Okay, wait. Okay, so e to the x is continuous everywhere. 0 is 0. Okay, but tangent of x tangent of x okay, where cosine of x equals 0. Continuous. How does it do that when I click? I knew I was gonna do that bullshit. I knew I was gonna flip it the wrong way. Oh my gosh. I love a Ronskian. Wait, am I tripping? Y1 is x squared and y2 is this. And it forms that. Oh, wait. Yeah, and I have no clue what to do after I compute the Ronskian. So I know that I'm going to compute the Ronskian, which is going to be, the Ronskian is going to be equal to, basically, it's going to be y1, y2, y1 prime, y2 prime, which is going to give me x squared, x to the fourth, and then this is going to be 2x, this is going to be 4x cubed. And then we basically do AD minus AD minus BC, which is going to give us, I probably should put that higher so I could have more room. Okay, so then from here I'm gonna get 4x to the fifth minus 2x to the fifth. Make sure. Yeah, 4x to the fifth, 2x to the fifth, which is gonna give me 2x to the fifth. Is my Ronskian. All right, after this, okay, and then we ask, is this expression ever non-zero on the interval from 0 to infinity? Yeah, when it's greater than 0. If yes, then the functions are linearly dependent. If it's identically 0 everywhere, it's linearly dependent. The theorem requires that w does not equal 0 at least one point on the interval. Okay, so Why does it do that? Why when I click enter, I don't get the satisfaction of the prompt going through? Okay, so it does not equal 0 for all x on 0 to infinity's interval. So then we conclude that's it? What the frick do they give me an equation for then? Okay. I'm gonna practice my proof writing. Therefore, comma, we can conclude that y sub 1 equals... Do I just put the thing x? Yeah, no, I didn't. All right, good. X sub 2 and y sub 2, sub 4 are linearly independent. That's it. Is that that didn't make too much sense, low-key. Okay. The Wronskian alone only tells you the functions are linearly independent, but linear independence by itself does not automatically make something fundamental set of solutions. The functions actually need to be solutions. You can confirm. Does it want me to verify? It just wants me to verify this, but if it said find a... Okay. I'm gonna put a line. Not my greatest line, but asked me to find a fundamental set. I'm assuming this is how we would find the fundamental set. Why does it keep doing that? Yeah, this is verifying. Actually, it did ask me to verify. So then we would do for y1 equals x squared, we would do x squared double prime, so that's 2x, that's 2, minus 5x 2x plus 8 times x squared equals 0. This would give us 2x squared minus 10x squared plus 8x squared 0. And as we can see, negative 8x squared. Checks out. Other side. Plus 1 equals to the fourth, we would do x squared, 2 derivatives, 4x cubed, 12x squared, minus 5x, 4x cubed, what's next? 8x to the fourth equals 0. This is 12x to the fourth minus 20x to the fourth plus 8x to the fourth equals 0. This is a negative 20x to the fourth plus 20x to the fourth equals 0. Verified. Okay, we're finding a fundamental. Yeah. I'd have to solve the characteristic equations. Oh, so I have to find y1 and y2. One solution was given. Reduction of order to find the... Oh, so this is P3. Literally what I'm about to do. Okay, and then solve the characteristic equation. Roots. And then verify it. And then the general solution is C1, Y1, C2, Y2. Okay. So, and I have to solve the characteristic equation. I have to use reduction of order. Can I just go to my table of contents? Okay. So we already have one non-trivial solution. Is this homogeneous? Oh, it is. It's homogeneous. And it already has that form of P of O. I have to divide by x squared. Okay, that's fine. 4 P3 9. Oh my gosh, why did they do that? Alright, so let's do this is literally killing my ears. Okay, so then we get y prime plus 2x y prime y double prime plus my division might be off, not gonna lie. Yeah. Yeah, I figured. All right. Wait, what did it just say? Oh. Sure. I'm gonna act like I understood. Not gonna lie. I think I did. Because this is really dy over dx. Okay. So now we know our p of x should be 2 over x, and our q of x should be this negative 6x squared. And we can directly read off p of x for the reduction of order formula. Oh my sweet Jesus. Oh wait, no, I don't think this is bad. It's literally right there in my face. Okay, so, oh, because we already know y1. Okay. So y2 is just going to be equal to, basically x squared multiplied by the integral of e to the negative, we're just going to do this over here, e to the p of x dx. This is gonna basically end up being e to the negative, that's already negative, so it's gonna be e to the negative 6 natural log of the absolute value of x plus c. So this is gonna end up being a plus. This is going to end up being like 6 ln x. And this plus c is included, so this is going to end up being a minus c. Hopefully. Minus c. That's going to go to the inside. What's on the bottom here? Y squared. Oh, y1 squared. So it's going to be x squared squared. So we're going to get x squared. Oh, wait. It's an integral. Good Lord. Okay, so it's going to be x squared. That should cancel out the e in the natural log. So then we would get basically x to the 6th plus this like c e to the x over x to the fourth. Okay. Okay. So that's actually a hell of a lot, I'm not gonna lie. And hopefully I did that right. What did I just do? Oh my gosh, I just mixed up my numbers. Bruh. My god. This should have been a 2. 2. Yeah, and that was a negative. So, and this would have been a plus. This was negative. Okay. Negative. This was a 2. I don't know where I got that. I was looking at Q of X like a dope. Okay, and then this would actually be a minus. See? This would be a x to the negative 2. Okay, yeah, they're right. This would become x to the negative 2. So then, why didn't they include, wait, hold on. But this makes sense though, because then this becomes, yeah, why didn't they take C? Okay. Okay, that makes my life a lot easier. Oh, I don't know why I'm using this eraser. I actually gotta stop. Okay, so then that makes more sense. Now we have an x squared to the integral of, those cancel out, that becomes a negative 2, and then we distribute the negative 2 to the natural log, so then we get this x negative 2 over x to the 4th. Why is it crooked? And this in turn gives us the integral of, with an x squared on the outside, of basically 1 over x squared. Did I just goof? No, I did, because it's negative. Oh my gosh. This is the stupid shit you do before an exam. Oh my lord. How can I rewrite this so I can understand it better? Let me do it like this. Integral of 1 over x to the 4th, x to the 2nd. I'm just writing it too big. It's bothering me. Hold on. Of x to the negative 2, x to the 4th, x to the 2nd, integral 1 over x to the 4th plus 2, x squared, integral 1 over x to the 6th. Okay. Dx x squared so then I'm going to get x squared negative 5 okay. I probably should simplify that, but it's fine. Am I tripping? Oh my lord. This is not the day to figure out how to integrate. Alrighty. Fun. So in the general solution, Okay, wait, this isn't bad. All right, and then to verify, we would just basically plug this in here. And this is reduction of order. Okay, it's not bad. Oh my Lord. That was so much fun. All right. Oh wait, I like characteristic equations. Can I come back to, oh no, these are repeated roots. Okay. It gets easier from here, boys. That's what nobody ever said. Does it get easier from here? Bro. All right, let me see. Okay, so 4p. All right. I'm just gonna make this. Why does it do that? Oh, maybe it's because O isn't. That's kind of crazy now. What is this? Multiplies to C, adds to B. 3 times 3. Positive. Oh, this was literally a question from my homework, repeated roots. When there's a repeated root, I don't know. The second independent solution. Oh my gosh, my typing is crazy. I do this when I write too. It's almost like I think I typed it, or I think I wrote the letter before I wrote it, and then I just skip it. So this would be e to the 0 x. That was trash. And then this has a multiplicity of 2, so this would be something like e to the negative 3x plus x e to the negative 3x, right? Because there's a multiplicity of 2. So then the general solution so then we have y is equal to c sub 1 plus c2 e to the negative 3x plus c3x e negative 3x. And this is the general solution. So now we basically just take our initial value problems to solve for our, what's it called? So for y of 0 equals 0, we basically get 0 is equal to c sub 1 plus c2 e to the negative 3, 0 plus c3x, which is supposed to be a 0, 0 e negative 3, 0. We get that basically 0. This all cancels out to 0. Same thing. 0 is equal to c1. All right, and then we do y prime of 0 equals 1. So then we get, we have to take y prime somewhere off in the cut. I think I'll put a sticky or something up here, wherever they are, where they go. Bruh. Oops. Whoa. Okay. So now we know y is equal to c sub 1 c2 e so then that would mean y prime would be equal to, I put the prime in the wrong spot. It's fine. Just call that same thing. Okay, this would be a negative, this would be c2 negative 3 e to the negative 3x. Ooh, this is a product rule. Fun, fun, fun. So this would be plus C3 e to the negative 3x plus C3 negative 3x e negative 3x. Oh my gosh, I just wrote it on my paper. It's fine. And then y double prime would be equal to, now that C2 is actually still there, but this is going to be C2 9 e to the negative 3x plus C3 negative 3 e to the negative 3x. I could have wrote that differently. Plus another small little chain rule here. So now it's going to be C3 negative 3 e to the negative 3x plus C3 9x e to the negative 3x. So plugging in x for x's and 1's, we get 1 is equal to, everywhere, C2 minus 3 e negative 3, 0. Wait, why did I just do that? This is actually not true. I don't know why I just did that. This is not true. Because 0 is equal to C1 plus C2 e to the negative 3 times 0 plus C3x e to the negative 3 times 0. This one is 0. This one is true. But this should be 0 is equal to C sub 1 plus C sub 2. This does go to 0, because that would be 1. Yeah, this one actually does go to 0. But this should be this, or that C sub 1 is equal to a negative C sub 2. Yeah, okay, so then we have 1 plus C sub 3 e to the negative 3, 0 plus C3 negative 3, where am I at? Yeah, 0 e negative 3, 0. This one is still going to go to 0. Okay. 1 is equal to, this one's going to be negative 3 C2 plus C3. Yeah. So I think we should solve for C2 because a negative C2 is equal to C1. If we solve for C2, I just feel like that'll work out better. So then we would have I'm having a brain fart. is equal to a negative 3 times a C2. We would have C2 is equal to negative 1/3 actually, let's do it like this. It would just be negative 1 plus C3 over 3. And okay. I'm gonna tell them to solve for, let me see. Honestly, it's too long to type, I don't. Sorry, I forgot to put the negative 1 in here, but okay, so now we're doing the y double prime. So now y double prime of 0, negative 4. Negative 4 is equal to, my gosh, C2 9 e to the negative 3, 0, plus C3 minus 3 e negative 3, 0, plus C3 negative 3 e negative 3, 0, C3 9 0 e negative 3, 0. This one definitely goes to 0. Negative 4 is equal to 9 C2 minus 3 C3 minus 3 C3. Negative 4 is equal to 9 C2 minus 6 C3. That's what I've got. Yep. All right. So I probably want to solve for C3 first. So okay, when I solve for C3, I basically get a negative 4 minus 9 C2 equals a negative 6 C3. Make sure that's right. So then I get two thirds plus gosh, wait a minute. 3 halves C2 is equal to C3. Two thirds plus 3 halves C. Oh, what did they want me to do? Oh, I should have inserted this and then solved for C3. Well, okay, that's plausible. That's plausible. That's plausible. Alright, so now solving for C sub 2, 2/3 plus 3/2 times a -1 plus C3, 3. Wait, what did I just do? No, just kidding. This is going to be equal to C3. Because we just inputted C2. So this is going to be, oh gosh. This is 2/3 plus 3/2 times a -1/3. I should do that, make it easier. Three over 2 times -1/3. -1/2. So it's gonna be ½ and this is C3/3, so this is no different from literally doing that, if you think about it. So this should also be, we're setting them equal to what, 6? So it should be like a 6 times 2. Oh, I don't freaking know. Let me do this for real. Let me be for real about this. Okay, so 3/2. That's what I've got. Yeah, that's what I've got. Let me see. I don't have time for this. Just no. Da 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 da. C2 is equal to a -2/9. And C3 is equal to 1/3. And C sub 1 is just equal to a -C sub 2, which is 2/9 positive. So then our final solution, our particular final solution, is y is equal to 2/9 plus, should be minus 2/9 e to the -3x plus 1/3 x e to the -3x. Bob's your uncle. All right. For P5, this is a very high nth order, but because we just want the general solution here as well, which is great. Because frick finding a initial value problem of a repeated root. So this will become r to the fourth minus 14r squared minus 32 equals 0. So, oh, I just put r to the fourth minus 32. Oh, multiply to C, add to B. What is that? 4 times 8 is 32. Or am I tripping? I was about to say 4 times 8 is 32. Oh, 16 times 2. We could do 16 times 2. So U there's gonna be a 16, there's gonna be a 2. One of them's gotta be positive, one of them's gotta be negative. I think this one has to be negative. This one's gonna be positive. So I got U equals, or U minus 16 and U equals 3. So then we get U is equal to 16. So it's really r squared equals 16. U equals 2, but it's really r squared equals 2. Then we get r is equal to plus or minus 4. R is equal to plus or minus 2. Which is also, I believe, a repeated root here. Oh, it's negative? My bad. It is. So it's a complex root. Sorry. It's a negative 2. So it is a complex root. It's plus or minus negative 2i square root of 2i. I have 2 different cases, distinct real roots, and a complex conjugate. What does this tell you about the form of the general solution? Maybe I'm gonna have something funky. I don't know. I'm gonna have can we do some? combination of both cases. So this is a real distinct root complex conjugate root. So from our r squared equals 16, where r is equal to r plus or minus 4, we get that y is equal to, it should be like what, c sub 1 e to the 4x, yeah, plus c sub 2 e to the negative 4x. And then from our r squared equals a negative 2, where r was equal to a plus or minus square root of 2I, we're going to get that y is equal to, let me try and put this together. C3 cosine of that. Okay. There's no alpha though. I'm guessing because it's, why did we omit? Oh, if it were a non-zero. Alpha is equal to 0. I'm about to ask how did they know alpha was equal to 0, but C3 with our cosine of the square root of 2x plus C4 sine of square root of 2x. And then how did they, am I tripping? Equal to 0. My head is killing me. Oh my gosh. Okay, so my general solution is y equals c sub 1 e to the 4x. There's no real part, and this is the imaginary part, and this is the general form. And since a is equal to 0, okay. Okay, so this is, so that first one's gonna be, oh, we're using the quadratic formula, I love that. Oh, interesting. Okay, that makes sense. So then alpha is 1, so then we get e to the, oh, okay. Okay. Bet. Okay. Yash. Bro. Okay. Undetermined coefficient, superposition with the modification rule. Y double prime plus 4y prime plus 4y is equal to this g of x. And this is undetermined coefficients. Let me see. Is this is non-homogeneous. Oh, let me find my roots. Multiply. Because C had to be, oh yeah. So this is going to be R. This is going to be 2 and 2. Oh. But this isn't going to be good because this is just going to be equal to the plus or minus square root with a multiplicity of 2. How do we do it up here? Yeah, 2i. A perfect square trinomial? Am I tripping? There's no way. Oh, I'm a duck. It's literally freaking r plus 2 squared. It's r plus 2 squared. Is that not what I just said though? But that's what I just said. Oh, I guess because it's not, it's only r squared and r, it's not r to the 4th. That makes sense. That's on me. So it's still multiplicity of 2, but it was just r is negative 2. Yeah. Okay. Okay, that's fine. And then we're following this form, which is e to the ax. It's a real repeated root. Okay. So its form is, yeah, where to go? It's like y equals c sub 1 plus. Okay. My natural trial function, and then expand it out. then I would get AX, yeah. Compare that against YC. Now we're going to deploy modification rule. So then we would get, one of these would be x cubed. Yeah. So then we would get yp. This is yp. Equals basically, let's do x squared times, or x squared e to the x, excuse me. Squared e to the negative 2x times ax plus b. This would give us ax cubed e to the negative 2x plus bx squared e to the negative 2x. I have to solve for a and b by yp1, 2, equation what time is it? 12? Okay. Okay, so oh yeah, it's derivative of the outside, derivative of the inside. Chain rule. or power rule, my bad. And then y double prime, okay. And then we substitute into this and matching the coefficients with 7 plus x. Oh, because yeah, I forgot. And remember. Y is equal to yc plus yp. All right, what's next? Oh wait, it's on the back. And this is resonance. Love that. This is the annihilator. Annihilator is probably what I'm gonna need to really, because I have no clue how that junk works, I'm not gonna lie. Not a clue in the world. I just knew it involves the letter D. That's about all I've got. Okay, so, okay, and then all the e to the negative 2x terms cancel out, which is right on both sides. So then you get 6ax plus 2b. After canceling, it's just 6 plus 7x. Oh, okay, so this is our left side, this is our right side. So the lefts and right sides must be equal for all values of x. So coefficients of each power must match. The coefficient of x1 has 6a, and the right has 1. Oh, I think I remember this. This is when it was like this. I think. It was the same as like just saying 6a equals 1. And then now this is the same saying 2b equals 7. Okay, yes. Okay. Okay. You pretty much get 6ax plus b, oh sorry, 2b is equal to the 7 plus x plus 7, or this is the same as just saying 6ax or 6a equals 1 and 2b equals 7. So then we get that a is 1/6. And then we get that b is 7/2. So then the final solution I don't even know where I'd put the final solution. Final solution. Would end up being basically y is equal to c sub 1, which is, oh, and then we apply, Oh my gosh. Okay. Y equals, I don't even know. This is the general solution. My lord. Okay. This is the general solution, which is y is equal to c sub 1 e to the negative 2x plus c sub 2 e to the negative 2x plus, we get 1/6 x cubed. Yeah, or we can do it this way and do, what the heck did they just do over here? Did I miss something? Why is there an X? No. Oh, there's supposed to be an X here. Because it's a repeated root. Plus, now we have the e to the negative 2x times this 1/6 x cubed. Yeah. I just put x to the 6th. Cubed. Plus b, which is 7/2 x squared. Okay. Word. Wow. If I had to guess, this is probably going to take me like 2.5 hours. Which is crazy because they didn't even have that long on the exam. I think our class is like an hour and a half, not gonna lie. I think. Okay. Alright, now for P7. This is a non-homogeneous. What's that's literally all I know. I don't know anything What's P10? Mixed review, third order equation. Why the hell? I don't think that's gonna be on there, but. Oh. And these trial functions are based off of if it's a repeated root, if it's a complex conjugate. And then we check for overlap. If not, then that's when we use the multiplicity. This is when we apply the constants. This is when we have like our AX and then okay. Okay, now I gotta write out a characteristic equation. So I'm gonna get r squared plus r equals 0. Yay! So then I get r equals 0, and then I get r plus 1. So, and then I get r equals a -1. Watch and be like, no, not exactly correct. I'm just gonna cry. Wait, how is that possible? Oh my gosh, I freaking forgot. If it's a y, it's just a 1. It's just the constant that's in front of it. So actually, yes, r is equal to the plus or minus 1, but square root of 1 is just 1, so. Am I tripping? Yes, I am. Because it's actually r squared equals a -1, which would then give us r is equal to a plus or minus, but they're saying the square root of 1 is, a square root of -1 is just an I. This is complex numbers. Good lord. So then these are purely imaginary complex roots. So for here, our alpha is 0, but our beta, or is it our, yeah, our beta is 1. So then our YC is equal to yeah, this is how I read it. The function my natural trial function. There's a constant, but actually, yeah. I'd probably do this form. Oh, I can handle them separately. Actually, simplicity is best. I'd probably go for something like this. Okay. I'll do a cosine of and this one I would do there's no e to the x, so that's why we didn't do. There's no overlap with that one. But c cosine of x. Let me switch this. So that means we need to resonance, which modification rule. So then we would get x cosine, yeah. Actually, I'll do it this way. I'm gonna get yp is equal to a cosine of 2x, b sine 2x plus x times c cosine of x plus d sine of x. Okay. That's good. Okay, so now we would just do, so now step 4. So we would take yp prime yp double prime then we have to solve for A and B. So then we basically get oh, yeah. So let me do this. So this is basically going to look like oh yeah. So for yp 1, this is going to look like oh wait. So they each get their own separate. Okay. This is important. So first and foremost, we would say yp1 is equal to then yp2 would be equal to let's call this cx cosine x d. I was about to say, so each of them have their own different coefficients. Or is it that yc just became yp? Oh no, it just canceled out. So this is the general solution. And then we solve for this. So we would basically do like yp1 double prime plus yp prime equals this function, solve for A and B. And then we would do yp2, yp1, the same function, solve for A and B. And then the general but they may have canceled out. Okay, So then, so we basically y equals c1 cosine. Ten-thirds. Plus so then I don't know if I have enough space for this. It doesn't seem all that bad, but kind of is that bad. Oh boy. Okay. When we say annihilating, we're just meaning like, yeah, getting rid of the function. Okay. Which I got. So for A, we're looking for something that's going to completely annihilate this function. We have a polynomial times well, this is really x inside of some, or a function inside of x squared. Or it's really this function twice. Okay. Okay. Is that e to the 2x? Yeah. What type is each term? Well, this is just a constant. These are all... no. First one is a constant. Oh, wait, no, just kidding. The second is a, I could be dead wrong. I'm not gonna lie. So now what? If that's it, oh my gosh, that's light. That's light work. Okay, let me try B before I get cocky. All right, so this is just a constant. So this is just gonna be D. Okay, now this one, oh wait, no, it's just e to the x cosine of 5x. This is basically e to the x times a trig function. So this one is e to the ax. That's literally what that is. So then this one is, does that have a name? It didn't even give it a name. I just said what it's annihilated by, but what is it called? It's fine. This is just gonna end up being basically D minus A, which is 1 squared plus 5 squared. 5 squared. Then B of D is equal to basically D minus 1 squared plus 1. Wait, but is that all together? Maybe. I might have, what's it called? Yeah. So I should have been. D minus 1 squared 2, 5. Yeah. I might do the annihilator problem first. What the freak? I thought this was gonna be like literally the worst part of the exam, I'm not gonna lie. I was literally pooping bricks about this. Okay, last one. All right, for C, we have e to the negative x sine of x, which literally the same thing. So we're basically gonna have, what, D minus a minus 1. So this is gonna be D plus 1 squared plus this sine of x is the same thing, so it's gonna be 1 squared. Is that it? No. Minus e to the 7x cosine of x. This is going to be, I don't know if that negative counts though. Does it? I guess not. Okay, so then this one's going to be d minus 7 squared plus 1 again. So C of D is equal to D plus 1 squared plus, okay, so, okay. I'm just gonna put what I got. I don't have time to tell them. Oh, so it is still combined. That's so interesting. Annihilators are actually tough. Like, I actually thoroughly enjoyed that. But yeah, that was actually fire. Wait, let me get an example of this one. Okay. Use the annihilator method to find the general solution. And here we go. Oh, okay. Oh, here's the e to the x, and here's the p of n, where it's 2, n plus 1, so it'd be 3. Oh, wait. Huh? What the freak? E to the ax, p of n is to the a. The a is 3, so it's going to be d minus 3, n plus 1, which is already 2, so it's okay. All right, that makes sense. Wow. All right. Characteristic equation. R squared plus 3r minus 4r multiplied by c and to b 4 and 1. This is going to be positive. Negative. R equals a negative 4 and r equals a positive 1. So then our yc is equal to c1 e to the negative 4x plus c2 e to the x. Oh boy. Alright, so now I gotta find the annihilator. So we have 16 e to the 2x, which is basically a constant times, it's basically this, but to the degree 1. So it's basically d minus, does it even really matter? Actually, yeah. It's d minus 2 times the polynomial, which is 1. I think. Oh, no, I think it's squared. Oh. What the freak? How is that possible? N plus 1? Isn't it supposed to be n plus 1 though? Hold on. This isn't making sense. Because polynomial of this degree to the x oh, but I guess the constant doesn't even matter, does it? Because I had a constant here for b. What did we do for b? Let me look at a different one. Oh yeah, something like this. Oh yeah, it would be d minus 1. Because it's just e to the ax. So for mine it is d minus 2. Okay. So then we apply d minus 2 to both sides. Okay. This becomes d squared plus 3d plus 4. I would have never known that, so. Just skipping steps. Now this is all equal to 0. Times y. So then factor and that'll go e minus 2 D multiplies to da 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 da. We know that's 4 and 1. Equals 0. D or R, if you will. The combined characteristic roots. So R equals 2, which is a new root. Annihilator. R equals -4. R equals 1. Known roots from P of D. Okay, cool. The new root R equals 2 is exclusively from AD, so which would give us Y. Is this complementary? No, this is the particular. Okay. Check for overlap. Okay, and then substitute yp back into the original equation to find y. So y double prime, this would be what? 2, 4. So we get 4a e to the 2x plus 3 times 2a e to the 2x minus 4a e to the 2x is all equal to 16e to the 2x. We basically get 4a plus 6a minus 4a equals 16. Because we took all those out. And then we basically get 6. Am I? Yeah. Yeah. 6a equals 16. A is equal to 16 over 6. 8 over 3. Yeah. So then, final solution is y is equal to basically c sub 1 e to the negative 4x plus c sub 2 e to the x plus 8/3 e to the 2x. I actually like that problem too. I really hope she doesn't. It's always when you're like, dang, I really hope this question isn't on there, that it's right there. It's fine. I have to leave in like okay, I think I'm good now. let's do this. Last one. My gosh. I don't even think third order is gonna be on there. Where did they get this from? This problem was not on the homework. Fine. This is homogeneous. Try and do this one by myself. Oh, I think I'm running out of lead. No, I'm not. Okay. Homogeneous. It's already linear. Let's go ahead. Test R equals -4/3. Okay, so 3R cubed plus 7R squared plus 10R plus 8 equals 0. I have literally no clue how to go about this one. That's about it, buddy. Look how nice it is outside. And we're cooped up in here like vampires. Huh? Dude, I don't have the mental capacity for that right now. Let me see, because I'm telling you, if that's not on, if there's no mention of a third root anywhere, I'm about to scratch this problem out. I'm not playing. This is not the time. This is not the time. I have to do better with doing my homework. I have not been doing my homework. Literally, I've not been doing my homework. But I'm gonna see if I ask her today if she'll let me like finish it. She probably won't, but never ever hurts to try. Where is the... This is literally stuff for... Okay, yeah. We haven't gotten here yet. Power series. You know, I think part of it is I have not been going to class for real. And that's why we're in this pickle that we're in now. I don't know what I've been doing. I've just been like programming projects and I've just been neglecting my homework. But I'm back on it now. Hopefully. I've just been doing other stuff that I find interesting. I find school interesting, just not as interesting as like programming projects and just doing cool stuff. Like, look at this. Luckily, this isn't a grade, but let me see if there's anything. I'm telling you right now, if there is nothing about a third anything on here, I'm gonna be a little bit perturbed. Oh, what do you know? I'll be damned. I'll be damned. All right, never mind. Just walk me through the problem. I have no clue how to do this. Damn it. That's so crazy. What is this? Qual? What the hell? Oh. Oh, wait. Okay. That's not bad. That's not bad. But here's the funny part. On here, it doesn't even give me that hint. So how would I know to get this if I didn't have the hint? I'm trying to figure out where they got that hint from though, because that's not here whatsoever. I didn't even know we had a textbook. Crazy. Yeah, I gotta get on it. I gotta start using my resources. Okay. So this is how we solve given the hint. Okay, if we're given the hint, then we get a characteristic equation, which I can do. 3r squared. Oh, sorry. 3r cubed. 3r cubed. 7r squared. All right. Now we test. What is that? Geez, that's -4. That's basically -4 cubed over 9. This is 16, positive. Ah, blech. Positive 16 over 9. This is just that. So this would just be -40 over 3. And then this is going to be 8. Okay. Okay, so then now we do 3. So I get -192 over 9 plus 112 over 9 minus 40. Let me just... $120 over 9 plus, I might as well just put this over 9 too, right? 72 over 9. Okay, and this ends up checking out. And then 3r plus 4 is a factor. I don't know how the hell they got to that conclusion, but we'll have to see. How the heck did they get to that? Oh, and then they use, oh my gosh. use polynomial division or synthetic division. 3r cubed, 7r squared, 10r 8 equals 3r 4. It equals the same thing. Solve using the quadratic. Okay, then we end up with r is equal to -1 plus or minus the square root of 1 minus 8 over 2. And as we know, this will be our A and this will be our BI. Well, it's not really BI, but it's beta. And that's our alpha. So alpha is -1/2, beta is equal to the square root of 7 over 2. I, complex conjugate. So then we have a -4/3 is our real root, and then r is equal to -1/2 square root of 7 over 2i is our complex conjugate root. So then putting this all together, that should be e to the negative, yeah, I figured. So then we should get y is equal to c1 e to the, did I get anything else? No, I just got r, so it should be e to the negative. Where they get that negative x over 2? I understand this, e to the -4/3 x, I get that, plus c2 e to the, oh, maybe it came from here, the real of this, yeah, it is, -x over 2, and then it'll be, yeah, times cosine, oh, okay, yeah, that makes sense. So all of this is actually a part of, I have to stop using the wrong eraser. Okay, so then this is the e to the negative x over 2 times c2 cosine of square root of 7 over 2 x plus c2 sine of our square root of 7 over 2 x, or c3, sorry. actually should be inside. Okay. And this is the general solution. Okay, and how did... Oh, I wanted to know this. Okay. I think that might be it. We have a leading coefficient of 3. Oh, they're equivalent. These are equivalent forms, because if r is equal to a negative 4/3, then we can also say that 3r equals a negative 4. Which means we can also say 3r plus 4. Okay. Row. That was that was interesting. Like 130. My exam's at 2. I didn't do the worked examples here, but and I also know how to do the Wronskian. Wait. I just did that backwards, didn't I? I think I did. Hold on. I think it's supposed to be like this. 15, 14, this should be 16, this should be flipped. Okay. All right. Now, I'm gonna take a break. I'll probably leave at like 2:30. So, I'm gonna take a... I cannot believe I didn't recognize the perfect square trinomial. Bruh. Alright, so now I'm gonna take a break. For like, I need an actual like a long break, I'm not gonna lie. That actually took like so much brain power. I had to hurry before it changed to 26. Okay. Bruh. Actually, I'll keep going. Oh wait, let me turn my mic off. Bro, my legs are cooked. Alright. I don't even know what to do anymore. I'm really just like that, tapped out. But we must continue forward. We must continue forward. We must continue forward. All right. I have to leave in like 30 minutes. So I'm probably gonna do, everything's pretty much done. There's nothing else for me to do. So I'm gonna set this to 30 minutes. Oh my gosh. And I don't know. I guess I just do some Putnam exam prep. Let me exaggerate the hell out of this. Okay, and then I'm gonna do literally the same prompt in Claude, and we're gonna see what they say as well. And it's so funny because I have ChatGPT, like premium ChatGPT, but I just prefer to use Claude and Perplexity. Wow, that was quick. Oh wait, no, it's still going. Bruh. 6 to 9 months out. Oh shoot. Oh wait, no, this is calm. Actually, no, this is calm. Exam. No, this is calm. This is actually just what I need. So yeah, this is actually calm. I got scared. I was like, what do you mean? What are we doing 6 to 9 months out from now? That's the exam. I actually have this. Oh wait, no, I don't have this book. I have G. Paulia, which I need to read. Which literally, oh, bro, Baby Rudin. Oh, they recommended Baby Rudin. Hell no. But it's next week is spring break, so I'm definitely gonna I'm taking the rest of this day off. Why are you putting in HTML? What the hell? Okay. I don't know why it's putting in HTML though. Why is it putting in HTML? I'm so confused. Okay. Understanding analysis, linear algebra. I actually have this book. My goal is to actually be able to like go through and read it for real. I got it because I was in linear algebra last semester and I already passed it. But this linear algebra versus what I took, the linear algebra I took was non-proof based. It went so much, like this went so far over my head. So far over my head. And then my professor, a good like math professor that I know, who actually need to respond to their email today. I'll do that after the exam. Yeah. Okay. AOPS. See, but I went on here and there wasn't anything. Oh, that's so funny. I guess I just didn't go on here. I should just go through like all of these, shouldn't I? I should just go through all of this, because I bet money. Yeah, I bet money I'm not gonna get all this right, for sure. My algebra is probably the most shaky thing. It's worse than an earthquake sometimes. Number theory, combinatorics, geometry. Then I have to go into, but see, that's the thing, I've already taken the whole Calc 3 series. I'm in differential equations, but I understand very basic differential equations. I've already taken linear algebra. I actually need to go over, this whole section was an exam, but my grade was so good in the course, I got exempt from the final. And I just had so many other things to do, so I didn't take the final exam, but this was literally what was on it. Vector spaces, linear, literally all the stuff that I need as a physics major, desperately. Abstract algebra, groups, rings, fields, deeper number theory. Okay, Baby Rudin, Axler, abstract algebra, Galilean. Oh, I've heard great things. I didn't even do that. I've heard great things about Galilean. Number theory. I'm gonna ask my professor, because she's such a goat. I'm gonna ask her for, once I get to these things, I'm gonna ask her for recs. A1, B1, clever calculus, linear algebra, number theory, trick, more advanced problem, blending music, context value. Working style. Problem solving big problems. Yeah. I heard about this one. Okay. Can I get like a timeline? Oh, official books. Oh, this is a good idea. Just do all the A1, B1s and then expand to the A2, B2s. And then like an hour. Yeah, the goal I would say is probably to get down to like, if I can finish at least A3 through A3, B3 on the exam, like I feel like that's golden. Or at least if I can start each problem. They don't give very much partial credit, so. Oh, yeah, I should record. That means I gotta go get one, because this notebook is for my projects, which I need to update. But this is for like my simulations and physics projects that I want to do. Stuff like that. So I probably am gonna have to run to either Target. I think Target has Moleskins. 3 to 4 days a week. 1, 2 proms. Okay, so is this thing done? Whoa. Wow. 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 They were not playing about this. Holy crap. Okay. weeks 5 through 18. The fact that we're starting from number theory is kind of scary, don't you think? March, April, May, June, July, August, September, October, November, December. They didn't have to go this hard though, I'm not gonna lie. Like they did not have to go this hard. What is this? Oh my gosh. Yeah, I'm not even surprised by this. Like, anything MIT students get their hands on, it's wraps. Okay, so is this a timeline? Like, what is this? My biggest gaps? No. Okay, let me give them their props. This is amazing. Thank you. Okay. But revise to this basically means that I'm gonna have to be on my absolute P's and Q's for the rest of this semester. Yeah, I'm really gonna have to be on my absolute P's and Q's for the rest of this semester because that's the only way I'm gonna be able to get this done. Dude, math overflow is so funny to me. Math overflow is the only place where like people will literally get upset with you for asking math questions. Like, this is not a math freaking forum for questions. Like, it's almost like it's come so far that now it's like if you're not asking anything about number theory, algebraic geometry, like the pinnacle, like people get upset. But I get it and I don't. Like, to some extent, if you're asking like why is 4 divided by 2 2, it's like, okay, like, you can probably put that on Reddit. This is like this is where the Terrence Taos, Terry T's go. Oh my gosh, it's still going. Okay, let me get you going. I've got like 30 minutes. Bro, this is insane. Honestly, can I put this right here? No, the magnet is strong enough, is it? Is it? Gosh, I'm so sorry. I know that was so loud. It was not strong enough. I'm just gonna put it right here on the desk. It's still going. That's insane. This has been running for like what, 2 or 3 minutes now? Did I just see ring theory in here? Ring axioms? Axioms? That's fine. We gotta persevere. It's the only way. He's an associate professor, combinatorics, current PhD students. Travis Dillon? Now this guy looks like he just has a fun time, man. This guy has a fun time. Can you do this for your thesis? Can you make a book? Oh shoot, that's what I would like to do then. I mean, I don't think there's anything wrong with like theses, like not at all, but I want to do something different. Like I actually do want to make like a book, at least for whatever I figure out I want to specialize in. Like I want to make a book so that it's as accessible as possible. Oh, I might use his notes too. He actually seems like a pretty fire dude. Postdoc at Caltech. Crazy work. It's crazy work. Wait, is it still going? Oh, bro, I was about to say, all right. Dude. Holy moly. You know what? I'm not gonna lie though. I'm not gonna lie. I love that they think so highly of me. I love that they think so highly of me. I love that they think so highly. Maybe I can't do math, but I don't think that's the case. 94 weeks from now is a year and a half. That's not December of 2026 when it's March. I'm utterly confused. What's going on here under the hood though? Let's talk about that. They put the CSS in here too? My god. What font is this? JetBrains? Mono? Oh, that's for the title. Man. I'm not playing any games. This is actually so cute, I must say. It's more so in a, what's it called format though. But I wish this was more like a paper, like printable. Not gonna lie, I don't know how I would like if I download this, yeah, it's downloading in the HTML file. the Professor Leonard. I love that they have like not out of date resources, like actually stuff that's dude. Oh, this is gonna be fun. Oh my lord. Do you ever feel like, wow? You have like that moment where you're like, wow, like this is actually like just a lot more than I thought it was gonna be, for sure. But that's fine, I don't care. Of course Terry T was a fellow. I'm honestly, I can't say I'm surprised. Okay, they might like not like me for this, but I'll probably start prepping for real tomorrow. No, I'm gonna take a small break. Actually, no, I will start prepping tomorrow. My brain will be fine. I'll take a break on Sundays. Oh wait. It's fine. I'm just gonna copy all of it into my notebook. I think that's what I'm gonna do. I don't want to do that, but that's what I'm gonna do. What's after physics 1 and 2? I should know this. I mean, it's really physics 3. No, I think that's it. Mock schedule with spaced repetition to go back and revise for the subject as well as what's the word I'm looking for? honestly, I'll have to input my textbooks too. All right, here we go. Taylor, classical, math. I'm just gonna go like this. E, E&M, Griffiths. So much. McMullen, X1, modern, classical, mechanics. Hollywell. I already did Taylor. Intro to mechanics. Putnam. Oh my lord. My bad. Mike and Ike. Quantum. What is it? Quantum computation. Boaz. Calculus. What else do I have? I think this is, what is this by? Heffron? And then once I finish this, I actually have to go. Heffron. Axel. Barnett, Zero Bang. This is just the first one. Okay. That might be it. That actually was not as bad as I thought it was gonna be. That didn't take as long as I thought it was gonna take, honestly. Oh wait, no, I'm spelling things interestingly. What does it sound like? Does it sound like so satisfying? Oh my gosh. Okay, and then I think that is all of mine. And then I have okay. That's gonna take it a bit. I can probably go get ready to leave. This is gonna take a little bit for 3 interconnected study documents. Yeah, we can take our time. But yeah, this is gonna be so fun. Oh. Okay. Yeah, we have a lot to learn. So much to learn. So much to learn. You know, I'm very thankful for artificial intelligence though, because this would have taken me probably days to get a schedule together. Proof foundations. I mean, I love that they do this though, like follow-ups. See, here's the other thing. I'm not the greatest when it comes to sticking to times. So like if I enjoy the theory that I'm reading or the textbook and like I go down a rabbit hole, like I literally may take 2 or 3 hours just on like reading. Like it's gonna be a little interesting to see how, yeah, it's gonna be interesting to see how I do this. And I gotta go, so. This is a big lift. I'm so dead. Alright. I'm probably gonna stop it there. This will do its thing. It'll continue trying to figure this out, but